the audibility of the voice and other stuff. The screen. Just put on the heads up or the thumbs up or something like that, which makes perfect, perfect. Uh, That's great. That's great. So it's more positive now. So I can start. So thanks. And I trust and believe that Hosna has already shared a cup of coffee and snacks with you during this break and energies in seeing on. So thank you, Hosna. You owe it again. So we are going to we are going to catch up with you in person. So let's time. So, good evening, everyone present. It's my immense privilege to join you today at the Faculty Development Program organized by Malaredi Technical Campus. So, it's a very exciting opportunity for me, and I wanted to extend a heartfelt gratitude to the entire organization and the committee, the administration, and the faculty members who has dedicated to advancement of the knowledge makes gatherings like this possible. So it's very good to see that the similar frequency people, similar minded people are quite interested to know more about the emerging technologies, as well as integrating technologies and enhancing technologies in everyday and out life. As we all knew that the technology is emerging like very rapid rocket pace speed every day. We get to know more things happening, more things being involved, evolved, deployed, executed in the testing phases, and many other such things. So I feel like certainly it has been given a great opportunity to me, and I thank you for inviting me to share the insights and the dreams about the next paradigm shift in the machine learning and the AI. And I thank for giving me the stage, Mrs. Nine, especially the Mallory Technical Campus. I have been listening to the different sessions since yesterday, wherein the quantum computing and quantum learning and all these things has been immensely in deep has been explained onto the sessions. If I think I'm going to continue with the same thing, I'm not going to justify myself because I have heard so many technical people will with the decades of experiences has shared their experiences and their knowledge with us. So for now, before I start, I would like to first applaud for every one of you who is attending the call, who is on the panel, who is on to the dignitaries for participating, because I see you are the people who are going to shape the digital future of India and the world, because under you, it is the students who are going to get these knowledge, and these knowledges are going to be implemented into the future. As we have discussed that we are having emerging technologies, unless you guys shape the new generation, we are not going to see the wonders. So first of all, a great lot of applause to every one of you who are doing this job. Thank you so much once again. So let's get on to the topic. The topic which has been given to me is classical versus quantum machine learning and the navigating the next paradigm shift. So let me just quickly go ahead and introduce myself a little bit again so that you get familiar with my face. This is me. I know it's not so like Shah Rukh Khan or something, but I trust like it's pretty good. So I'm serving as an country head into the Credo Technology Services based in UAE. We are across the globe in more than 8 countries, including India. So I'm managing India. Apart from this, I manage Middle East region, followed with the European uh, area. So I come along with the 2 decades of experience with me and a PhD in computer science and engineering. So, excuse me if I'm not going to be up to the mark as you people do every day. You are the lecturers, associate professors, professors. I'm not into the academic side, so just excuse me and forgive me if I commit any sort of mistakes or not up to the mark. in your views. So now the agenda, what we are going to have the discussion today, and why we are here, and why this topic has been assigned to me. As I mentioned, that the topic given to me is the difference between the classical and the quantum machine learning. So the agenda, what we are going to discuss today is like, first we are going to focus what is now. That is, the now is classical machine learning and the power and the limits of it. What could be the future? That is going to be the quantum mechanics or quantum machine learning, including the quantum mechanics and the quantum computing concepts being driven or collaborated. Then we have got the role that we are going to play for the next generation, how we are going to prepare it for the next generation. So these are the main three things that we are going to focus, which is going to include what would be the next of like quantum computing demystified, and how it is going to be head to head practical comparisons. So I trust and believe that the agenda is quite clear, and we are going to continue with the slides. And by the end of the presentation, definitely I'll leave some space for your questions and for your discussions, so that we can have more understanding and classification of the understandings that we have got. So before we go with the quantum computing, quantum machine learning, classical machine learning, it is must for us to understand what exactly the machine learning is all about. So the machine learning isn't an abstract basically. It is the invisible field behind much of today's technology, that I can say. From our phones to our emails to the content suggestions that we receive every day. Unlike the traditional programming where every step is mapped out, machine learning systems learn from data spotting patterns, drawing inferences, and adapting without hard coded instructions. So it is more of like, it's a part of every day to day life. It's a part of every activity that we perform. Unlike when we talk about the traditional programming, wherein we define everything step by step, uh, but these things are more advanced in it. Let's take an example. I trust and believe every person is using a smartphone, right? In the smartphone, what differences that we have figured it out before, with the traditional phones that we used to use in about a decade before. Certainly, everyone would have at least seen 3310, 1100, or something like that, wherein we used to have the analog mobile devices, wherein we can just receive the call and answer the call, send the text messages, or play some snake kind of games, right? Which keeps us all occupied every day. So we have traveled from that era to the smartphones. Now we can see that the phones are much smarter than what we are now. They can analyze is your voice. They can work on to your biometrics, your facial recognitions, your instructions, whether it's verbal or whether you have created any workflow onto your mobile devices. Let's assume or take the example of speech recognition. The Siri understands your voice and commands. You keep your iPhone because Siri is an iPhone. And if you are using any Google kind of a platform, certainly you'll be using the Alexa. So it recognizes your instructions and the voice commands and work onto it. How do it do? So this is all happens when a certain amount of data is being fed into the machines so that they can learn on to those sets of data and work onto the instructions given to you. So we say it is the technology powering devices that we use daily. In the similar way, we have got smart instructions or smart homes or smart infrastructure, wherein if you're going to just give the commands to Alexa, it is going to turn on or off the lights, turn on the geyser, AC, or any such activities that can be done by a human. And at the same time, it's not only restricted or limited to these activities, but at the same time, in the background, when you are sleeping and you have got box full of emails in your inbox, and you don't know when you step in tomorrow and open your inbox, you'll find so many emails. Could be more of them are spam, phishing emails, or even the genuine and legit emails. Then it would be very difficult for you to differentiate or from the pile of emails that is being stored in your inboxes. You will go ahead and do the manual job of like filtering those things and deleting the stuff and making your inbox clean with the necessary or focused emails. So this is the normal or general activities that we perform every day. At the same time, people who are for entertainment, they could they could easily differentiate or figure out the suggestions that is being given to you when you're getting onto any of the entertainment platform like Netflix. If you have watched a movie of your favorite actor, suddenly you will see that there are similar suggestions associated with that particular actor. So how these things work? This works on the concept of machine learning. So what happens is like a huge amount of data is being fed into the machines wherein they understand, they they are built to understand the instructions and analyze the data which is being fed into the devices, especially onto the servers that we talk about. And they figure out the patterns, the procedures, the flow, and then they are going to work according to the behavior that has been instructed to them. Let's take an example of the spam detection email that comes into your inbox. You have got so many emails uh, with the subjects like winner or lottery or say as offer or something. So these are the humans who can easily differentiate between these emails, but not the machine. How we are going to make the machine work and think in the same pattern of the humans. So what we do is that we start machines to learn how a human mind processes. It was very difficult and it was a kind of a dream in about 80s and 90s, but they did a very hard work and they have made such kind of algorithms which can understand the patterns and the procedures and the flow, and they have enhanced it to the level where we can see now that they are doing the speech recognitions and smart controls and detecting the emails as well as suggesting you the what to watch, what not to watch, what are your choices. Again, for the ladies who are much interested in doing online shopping, certainly if you start browsing for any favorable sari or suit, definitely you are going to get those kind of ads, right? So how it happens? It happens because we analyze the user's behavior and the pattern, and the machine work according to your patterns. So I'm just giving you these kind of silly examples just because that I want you to smile. It shouldn't be a dry session for you, so that it comes up with some positive energies. So so this was a fun what I use while I speak onto the stage. So this is how we have discussed like why machine learning, and you'll get to know why I'm talking about the machine learning, because we need to understand the base of machine learning so that we can implement the different domains in the science that can be utilized in the especially in the engineering science, I can say, because whenever we are studying engineering, I remember the first year is going to comprise of all the necessary subjects, whether it could be electronics, whether it could be mechanics, whether it could be drawing, whether it could be computers, could be physics and chemistry and other things, because an engineer must be aware of all these basics. So the intention of teaching an engineer into these different engineering subjects is because that wherever it is possible, we are going to collab with different domains and make a very advanced mechanism that could make our lives easy. So over here, what happens is like we just learn what is machine learning, and now we are going to see what is classical machine learning. Actually, classical machine learning is an existing uh, technology in the current world, I can say. Let's take a deeper look how classical machine learning works, and we'll take an example. Similarly, like I prefer to go with using email spam detection, for example, so that it is going to give us more understanding because every day we are going to make use of the emails. So what we are going to do is like, as we learn about the machine learning, it's nothing but the data collection. That is like we have got thousands of labeled data classification into the databases, wherein the machines is being trained how it is going to work. So over here now, when we say that we have got thousands of data information given to the systems, let us consider a part of it. We are going to consider emails. So what we are going to do is that we are going to give the computer thousands of emails labeled as spam or important. Next, what we do is that we ask it to extract features. What kind of features? Like human defined features. So, how a human is going to behave when he gets the emails, let's say a subject line as like a winner or a lottery or something. It's only the human mind which understands what is the difference between a fake email or not important email and the important email. So what we do is that we learn the things, we put the similar instructions to the machine to understand. Let's assume like if an email has got $sign on it, and we say that if you see more number of $signs or any specific special symbols, we the machine can think it of as a suspicious email. If there is any such unknown link, also, we train the machine to think if you get these patternized emails, these patternized contents, these patternized URLs, consider them as a junk or as a spam and keep it into a junk folder and spam folder. So we have got algorithms like Naive-Bayes patterns and build onto the mathematical rules to spot spam based onto these clues. And every email, the trained model is going to automatically label it as or a spam or a not a spam. So classical machine learning is like training different diligent assistants. Imagine that you have got a team of 10 people around you. You are training them how to differentiate between a legit email or a legit person or a legit information and how they are going to behave after they receive your instructions. Similarly, we are going to put on these sort of analysis or instructions into the machines. We train them. It is more of like a diligent assistant for you. And what they are going to do, they are going to differentiate or filter these information based onto the instructions that we have given them. So how we train them is not only the information, it's not only the labels, it's not only the behavior, but also what we do is like we show the machine different examples. So in this way, a machine is meant or has been educated uh, to differentiate between the necessary information. So in this, we have got abstraction or extraction of the information. Then what we do is that we train the model with the algorithms, and then what we expect the machine to perform or behave in the way that a human thinks and does the job. So this is the classical concept of machine learning, which is in place right now. Wherever you go, you can find, if you notice, you will recognize that, okay, this is basically a computerized program which has been trained, which is nothing but a machine learning platform with the classical methodologies, with the algorithms, and it is trained in such a way that it is going to filter or process the things in this particular fashion. But what happens? Everything comes up with the limitations, or what we can say is like the more we start using the things, we'll get more requirements. So there we get the limits being set. This is how I explain to the people. It's more of like, if you are using it more and more, then you'll get to know the faults and flaws, or you'll get to know advancements or enhancement that we can. So think of using a regular flashlight to search a vast cathedral. You'll find things, but it will take you an incredibly long time for this. So what happens? Imagine that you have got something to search, and you, being a human, you know all the possibilities, and you're searching for a cathedral into a dark room, and it's going to have it's going to take you approximately 30 minutes with a flashlight searching around here and there, etc., and etc. Imagine that you have got more such people around you with the same instruction set, and you can do the thing or do the job within 5 minutes instead of 30 minutes. What happens? It happens in a way that we are saving the time, we are making it more robust, we are making it more faster, efficient. So it's more of like you're saving your time, your energy, your processing time. And when we say that time is money, yes, literally it means time is money. Imagine that you have got complex problems like molecular simulation of a drug discovery. At the beginning, I remember that I discussed that every part of the engineering is being taught to the engineers so that we can make more advanced mechanism. Now, when the IT is all everywhere, it's into the finances, it's into the economics, it's into the computation, it's into the mathematics, it's into even medicine. You must have heard about the robots who are doing the surgeries. You must have heard about the machines practicing computation process of the chemical bonds for the pharmaceuticals. So imagine if we can collaborate all these different technologies into one place and prepare one super machine or one super algorithm or one super device that would do the job of hundreds of doctors or experts and get the information within fraction of minutes, how the life would be. So, if you have got complex problems, as I was discussing about the science and the medicine, consider the molecular simulation of a drug discovery. So, the classical supercomputers would require thousands of years. We need fundamentally brighter approach. So, we have got already existing classical machine learning algorithms which could do computational process, but now we have realized that this time taken by the classical method that we follow is not being enough for us. We want to get these things done at a very high speed. So, what we thought is like, what if we are going to introduce quantum computing to speed up the process so that we are going to advance and enhance the classical machine learning to the quantum machine learning? What if we make the machine to work at a very high speed how the quantum computing does? So how it is going to be the world in the next few years, though it is still into the production, though it is still into the testing, unless we have got these thoughts and implement these thoughts, we are not going to achieve the great heights. So we started with the quantum computing things to be deployed into the machine learning strategies and the algorithms, taking or uplifting the classical machine learning algorithms to the next level, to the quantum machine learning algorithms. So let us get on to first understand what is quantum computing, and then we are going to discuss more about how we are going to introduce this quantum computing concepts into the machine learning so that we are going to make it as a Superman. We must have seen Marvel movies, right? We have got so many Marvel characters like Iron Man, we have got Superman, I don't know, Captain America, and all, right? So we are going to get all these kind of specialized technologies going to be collaborated together to enhance the computational process and get new advanced uh, devices servers, systems, which is going to make our life easy. You must have studied in the previous session. I heard Mr. Dr. Akbar has been well in depth described about the zeros and ones uh, and NOR gates, and how the cat 0, cat 1 values is going to be calculated, how the quantum mechanism is calculated, how it is implemented. So the same structure follows here. So I don't want to bore you guys with the same repeated discussions that has been done in a very perfect manner earlier. So we will just do the touch-based concept here. So we'll be just discussing about like what is quantum computing. It is nothing but a quantum computer is a machine that performs calculations based on the laws of quantum mechanism, which is the behavior of the particles at subatomic level. So when we are talking about the low level things, how we are going to first we need to understand what is quantum computing. And once we understand the quantum computing, how we are going to implement it into our existing chipsets, or we can say as like technology or the patterns. So this is where it is important for us to know what is quantum computing. So basically, it's a revolutionary conceptual paradigm that harness the principles of the quantum mechanisms to process information, unlike the classical computers, which relies on zeros and ones, where we have got linear approach, either zero or one, and then beyond that, we have got the quantum computers set of data, which we call is an qubits. As you knew that it is zeros and ones going together all at once, but not following the linear pattern. So it can exist in the superposition with both zero and one simultaneously going parallelly, increasing the computational process. And it is a phenomena which is as such that it is going to entangle and quantum interface in a way that the computers is going to have an exponential speed. So now, when we have got instructions given to the machines and they can perform the job, but if the same instructions was given to a human earlier, it is going to consume at least 3 to 4 hours. Now, the same instructions, if it is given to the computer without any interference of the human, what to do, what not to do, the machine are capable of executing those instructions in a very fast manner, taking their own decisions based on to the algorithms that has been set for them, and performing the job without any presence of a human. Imagine from 80s, we have reached to 2025 and we have got these enhancements. And every time we have got these enhancements, it is taking us on a level, onto the next level. So when we have got these classical machine learning algorithms already in place with very less computational time, and if you are going to power it up with n, let's assume like x to the power of n is going to be the quantum power, the speed with which it is going to do the executions. So here we have got a brighter light onto the quantum computing. So just give me a moment. So it's more of like we were talking about like bits, and then we spoke about qubits. Qubits are like spinning coins, unlike classical bits, which are either zeros or ones. And qubit exist in superposition that we discussed just in the previous slide, wherein they can be either zero or a one and can perform at the very same time parallelly. And we have got entanglement, which is kind of an spooky connection. And what happens with this is like qubits can become mysteriously linked. That is like meaning you can say as measuring one instantly affects its partner. No matter the distance, they are connected with each other. It's more of like, okay, you do some changes here, it happens there, they work parallelly. And these quantum properties allow for what I can say is like unprecedented parallel communications or computations, like processing of countless possibilities simultaneously instead of one by one, or a linear approach that used to be a traditional way in the classical uh, machine learning process. So it would be better if I give you an example. to much easily understand the concept of quantum computing. So let's take an example that you just stepped into a library and you find a librarian. He is working there for ages. Let's assume that he is there for nearly about 5 to 10 years. He know where the books are shelved. If you go out and speak to him and you ask for quantum physics textbook written by Dr. X, so when you speak to him, what he does is like he will quickly go there and pick the book up for you and bring it to you. What if you did the same job all by yourself? Certainly, it is going to consume some time, at least 30 minutes, because the library is huge. It has got thousands of books into the shelves. So it would be very difficult for you to go and find the index where the book is and then pull the information. So, what we are going to do in the quantum machine learning approach, we are going to give this uh, librarian magical powers. So earlier, he was smarter than us just because that he was there for more than ages. He knew the procedures, he knew the indexing when the books are placed. Now we have given him the magical powers so that he can visit every shelf simultaneously at the same time. Imagine if a query has been given to the classical method to find out with a linear approach to find out a book, which is going to take 30 minutes. Now, this same librarian, when given the magical powers, it could get the book in a second. How? Because the computation process has been advanced quantum level. Earlier, it was linear, it was classical. Now, it is on to the quantum level. So, the key insights, what we can say is that the quantum machine learning uses superpositioning and entanglements to analyze all possible data patterns at once, not like the traditional one when we have got linear approaches, and finding the gold among haystacks and instantly. So it's more of like you are saving the time, you are saving the execution and computation process, and all the things is happening just like in a click, just like in a fraction of milliseconds. So now what happens? How the quantum machine learning algorithms are in action? How do they perform? So imagine, I'll give you another example here. Imagine a complex maze. A maze, hope you understand, everybody knows what is maze, right? It's a design wherein you need to find the exit. You have got so many, yeah, the same picture that you could see onto the screen at the top. It has got a similar walls wherein you step in from one end, you need to find out the exit. That is called as a maze, right? So, in the classical algorithm, a single explorer tries each path one after the other, hitting the head ends and backtracking. So what happens is like he just walks in, he walks around, and he reaches to the dead end. Then he realizes that okay, there is no way out from here. He roll back and take another approach and gets into the next path to find the exit. So this is going to take at least 30 minutes. Let's take an example. So X amount of time to find out the exit. So in the quantum, what happens is like every single path is going to be executed or analyzed at the same amount at the same time. So within fraction of milliseconds, the exit is going to be discovered. So the maze is instantly going to be, it's more of like you are flooding the light across the maze, wherein you see the light is traveling from every path, revealing all efficient paths in a single moment, rather than going and knocking your head onto the dead end and then coming back. So for challenges like finding the best route, the strongest material, or the perfect drug molecule, or any kind of quantum speed up transformations, the possible approach would be applying the quantum mechanism into the machine learning process and enhancing the machine learning and the regular day in and out operations and executions. If the concepts are clear, this picture or this tabular column will certainly give you much better clarity or an understanding of it. So here's the reality. What we can say is more of like classical machine learning is reliable, production ready, widely available, as well as it excels at the targeted optimization. It operates at a polynomial scale, solving many practical problems in business and research in today's world. It is already existing thing. What we are trying to do is that we are going to boost it up. So when we say that we are trying to boost it up, that means that it is still in the experimental phase with a limited access, with more specific optimizations of the existing algorithms. And at what speed? It is going to be an exponential potential of speed to execute at a very high performing status statistics, I can say. So certainly when we are going to deploy this high end advantageous advanced enhanced technology, where we are going to involve all the chipsets that we have been discussing from the previous sessions of the nodes and circuits, AND gate, and other calculations, it is going to be a bit expensive at this point in time. The classical machine learnings remains dependable workhouses for now. When quantum machine learning, I can say, is like it is an emerging or emerges with a specialized super tool for momental and solving complex challenges. So this is the basic difference that can easily give us some idea, as is it is still in. But if this is going to be, it is going to be ready in a very sooner time, it is going to do wonders. And where it is going to shine, where this quantum machine learning is going to be utilized, I can say in every phase. As we were discussing about the medical domain, wherein we spoke about like calculated for the pharmaceutical domain, where they are going to calculate the different permutations and combinations for preparing the medicines. Similarly, a drug discovery can be enhanced and can have very less time. So what I can say is like machine learning concepts or quantum machine, basically, while we are discussing the quantum machine learning, is going to excel in finances, in healthcare, in material sciences, in supply chains, in logistics, everywhere where there is the involvement of methodologies with the algorithms, with is taking, like for now it's like okay time, but if you're going to boost it up, imagine a warehouse of Amazon or say as Flipkart or any such uh, online shopping centers wherein you have got immense amount of materials stored into the storehouses. It would be very difficult at this point in time to process the number of requests that is hitting to their servers. So if we get these applications really working very fine with a high speed, the supply chain is going to be on to a next level. Imagine where we are speaking about crores and trillions and millions and billions of GDP and financial things. These super high number calculations can be done in fraction of seconds. Though we are doing still doing it, but as every day these things are increasing, certainly we need to have a very high speed stuff. And at the same time, we can put these things into the material sciences, we can put these things into the medical sciences. And I remember when Mr. Akbar, Dr. Akbar, was discussing about the different applications and different study levels of the algorithms. He was discussing about the IBM Qiskit and many similar applications or platforms, which is doing a good job, but after implementing these things, it is going to be a super sonic kind of a speed. I trust and believe that you guys watch movies, right? And if yes, certainly you or any of your kid would have certainly seen a movie recently called an Sonic the Hedgehog. Imagine the speed with which the hedgehog runs and gets the things done. So it's more of the same, like you are getting the quantum things, getting at the very high speed, doing the jobs efficiently in a very fast pace. So over here, let's see like what could be the current limitations with the existing setups and how it is happening and what we can do with these things. Currently, we are in a noisy intermediate scale quantum era. That is, the quantum machines, while promising, are still prone to error and instability. Why? Because I just said that we are still into the experimental phase. So over here, noise is not a physical noise that we are talking about. We are talking about the machines which is going to experience errors, problem solving, and many such use cases which is coming in and they are working onto it. And they are finding the gaps where we need millions of stable qubits for general uses. We currently have only 100 ones. So we are trying to fill these gaps. Most effective solutions today that we use in the quantum are coprocessor. That is a boost for the hardest parts of the classical algorithms, not yet at full replacements. So we are doing these things. We are trying to get these things into place. We are getting these things to be more advanced. And we are trying to get quantum kind of technologies, quantum speed into the existing classical machine learning algorithms. And I still remember that Dr. Akbar was focusing more towards the cryptographic crisis and algorithmic bias and access of divided quantum energy, or how it is been how it was a risk. There is basically a risk of creating a gap between those who have access to the quantum power and those who do not. So these are the things that is still a challenge for us, that is still uh, we are working, we in the sense like the technical teams across the globe, the specialists, and they are working on it, making it more happen and get into the existence very fast. So just not to make this more dry or something, let me just do one thing. I'll just play a video which could summarize all the things that I was been talking all about in literally 3 minutes, which could be a kind of a summary for you guys, like what we have spoken about, what the previous presenters have spoken about, and it could be a kind of a refresher. So let me just quickly just stop presenting my slide here and go to a video that I wish to play for you people. So just bear with me over here. Where I am. All right, here I do. So I'll just make it full screen. All right. Can anybody help me that you see the full screen of a black background video?
Yes,
Just
sir.
unmute because perfect, perfect. Thank you so much. So let me know that as well, okay? If it sounds as well and good. So I'm just trying to play it. Is it audible? The audio?
No, sir.
Possible. No, I just paused it now. So I'm going to play it again. So let me know if you could hear something.
No, no sound, sir.
All right, there is no sound. All right, fine. Thank you for notifying me. Let me just find out how it's going to work. Mm, mm, mm.
Maybe I think, sir, while sharing, there will be one redo button checkbox. You can check it out. So that the video within the audio will be played.
All right, so You want me to go to the audio? That's what you mean?
During sharing the video,
Oh,
it will ask the screen that there's a audio in the slide should be played. Maybe that is the way I hope.
I'm very bad in this. I'm so thank you so much. Chikala night, right? All right,
You have
fine,
to check
perfect.
box it.
Yeah, yeah. 1 second, 1 second. Just go back. All right, there I am. So come here, go to the screen, Firefox, this window. Mm-hmm, mm-hmm. No, I guess like I need to do it in a different way. Mm, where I am here, play the screen, share the window, share the window, this window. All right, so no, it's not giving me an option for the audios. Mhm. So if anyone from the panel can help me playing this video, that would be of great help. If that's okay.
So you can share the link in the chat box. Maybe someone play.
Yeah, that's what I was thinking of. Thank you so much. So the chat box, where is it? Mm, background reports. I'm not very much familiar about this Google Meet. I used to do the things on Teams, Microsoft Teams. So what I'll do is that I'll share this into the group. I'm sorry for this. Extremely sorry for this. All right. Let me see. Open queue. Search people. Mm, got you. Yeah.
Yes, ma'am.
So yeah. Oh,
No, ma'am.
no, 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 it's not audible. That was a challenge. I was listen. So but it's, it's being so anybody can go through the video once we finish the presentation. It's just like a summary what we have been discussing. No, it's not audible. All right. So, Mr. Snan, let's do one thing. Let's drop off this plan of like watching this together. Anyhow, the link has been shared in the chat box. So, what we are going to do right now is like we are just going to focus the leftover presentation. I have already taken enough of your time. I'm so glad that everybody was quite interested and keenly listening to the discussions that has been done. So let me wrap this up very soon. It's already sorry, 9, and I think like the snacks that has been offered by you has almost been finished the energies that they have got. So so this is where we are right now. So I guess like this was the last slide once again. I trust. Okay, this was the last slide. And now, what role that we are playing? Remember that at the beginning, we have been discussing about the five things. Where are we right now? What is going to be the future? What are we going to do, etc., and etc. And I have started the discussion and the presentation praising every one of you onto the panel, onto the participant list that you are building the next future. So, in this way, as a faculty, academic leaders, you are the bridge builders for this transformative journey. Here is how we can prepare the things for the next generation to understand the things, how they are going to utilize, how the knowledge is going to be transferred from you to the next generations. Patients in linear algebra that is most probably and algorithm designs, how they're going to design and bring the quantum aware perspective to the traditional courses. And this is you who is going to knowledge transfer, the integrate cloud-based quantum simulators like IBM Qiskit and Google or Microsoft QHash into your coursework, giving the students hands-on experience. I don't know how the current academic syllabus looks like, but we can encourage the final year students to project and explore hybrid quantum classical algorithms, develop interdisciplinary modules such as like quantum information sciences that could bridge the physics together. It's more of like we need to have a mission to create quantum among the engineers. So what I say is like, let me just conclude this discussion by saying the quantum future is not a distant dream, present reality requiring immediate preparation, which is you, everyone on the call is going to do together will equip the next generation to navigate this paradigm shift. And these discussions should be continuous, should be between the teachers, between the faculty, between faculty and between the academic advisors, so that if these things, if the engineers are thinking out of the box, we are going to. So that's it from my side at this point in time. And I thank you all for joining me today and your commitment, patience, listening to me. And I appreciate the commitment that you do for shaping not just the future of our own campuses, but for our entire technological landscapes. So the desk is open for any questions. Yes, we can have a discussion. So I'll just go for a moment so you can throw some questions on me, catch and get the thing out of the boundaries. So you can unmute your ask the questions.
இவங்கள பார்த்தா உங்களுக்கு கல்யாணம் ஆன மாரி தெரியுறாங்க. ஓ! அப்போ உங்களுக்கு கல்யாணம் ஆகலையா? அப்போ உங்க சிஸ்டர்
Ma'am, ma'am, if possible, please share this session recording. Okay, sure, ma'am. Thank you.
Oh, sure, sure. Moment. Wait 1 second. Let me see if that works for me. Yeah, let me just put on some filter. It's all off my shelf with books. Yeah, great. So I take this as like we don't have any questions at this moment. So before I close for the things, let me just say
So there is a
words for
question
you.
with the chat.
Yeah, please go ahead.
You can answer. I will answer. Miss Swati,